Hello, everybody. I'll put this over here. All right. So, in this lecture, we're going to talk about graphs and tables. So, when we're looking at a table is just showing data that has been collected from things. So, when we look at a table, we can really determine what type of graph we can make from this data. So, if I look at this data and it says most popular pizza, so they just took a poll on or they took data on what pizza, let's say Pizza Hut sold the most, and they sold 10 pepperonis, 7 Hawaiians, 6 cheese, 3 the works, or 4 the works, and 3 veggie. All this is showing is a bunch of data on what pizza do people order the most. So here you can't really do a line graph because a line graph wouldn't really show the data in a way that makes a lot of sense because you just see this line here. You'd see this line, and you'd see, okay, you got pepperoni here, and then you'd see this line or be up and down and down and up, and it doesn't really make sense. But if you do a different graph, like a bar graph, okay, well, I got 10, 10, 6, 7, 3, and 4, and then you just make a bar graph out of it. Bar graph. Okay, I can see what pizza is ordered the most and what's the most popular. It'll be nice is if they had these graphs at restaurants to like tell you what's ordered the most so you know what's most popular, but you can just ask your waiter. But it would be kind of nice. So, but I always tell everybody I'd use a pie graph on this because it's pizza. It's pizza pie graph because you could use a pie graph to show this data. Now, as we move forward, we're still recording, right? Yeah, okay. All right. We're going to look at this graph. So here, one thing that it says in your notebook is that when we're looking at the axes, the x-axis is the horizontal axis, the y-axis is the vertical. So x is horizontal, y is vertical. And with the x-axis, you want to put the most consistent or constant set of data there. So in here, you can completely just get rid of plant group because it's irrelevant when we're talking about the pH of the soil and average plant growth because this is all about the plant growth in soils with different pH values. So you would put the pH here, pH of soil here, and you would put the average plant growth in centimeters here, average plant growth in centimeters. You always need to have the units on there. If you don't have the units, you don't know what you're measuring in and what's going on. This is already telling you what the unit of measurement is. So, right, in here, it's just looking at, okay, at what pH does the plant grow the best on average? Well, this would be a great time to do a line graph because it'll show, based on what pH it is, which soil grows the best. Now you could do a bar graph with this as well, but it's more useful to do a line graph. So we got 6, 6.2, 6.4, 6.6, 6.8, 7, and 7.2. And then you got 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. So at 6, we've got 25.5. I better label this or I'm going to get confused. 10, 20, 30, 40, 50. All right. So 25.4, 33, right in there. 50.8, right there. 6.6 is 53.3, same with 68. 7 is 30.5, right in here. And 22.3 right in here. All right. Now, you could just connect the dots on this, and you would be fine. But if we're asking questions about, oh, what would the average growth of a plant be in a pH of soil of 6.7? What if we ask that? So that would be right here, and we want to know what's going on right here. Well, we wouldn't know that just by connecting the dots. So what you want to do is what's called the best fit line graph. So you're going to kind of go around and try to connect the dots as best you can, but stay kind of in the middle. It's more of a median because you would have lots of different points all over this at different pHs. And so you kind of want to go in the middle. I hope you can see those dots. Okay. You kind of go right through the middle of those to show, okay, now I can find an average. Okay, what's the pH, or what's the average plant growth from a pH of 6.92 or something. So you go up here. Okay, now I can find kind of what the average is. Okay, 31 centimeters of plant growth. Okay, so this is a best fit line graph. You can also just do a normal line graph where it's just showing you connect the dots. So that's two different types of graphs. All right, so let's look at a few different graphs. Now this one, there are a couple problems with it. I mean, it's labeled and things like that, but there's no measurement. We don't know what they measured in. It could have been inches, it could have been miles. Of course, it's probably centimeters if this is a scientific project. Another problem with this column graph is a lot of scientists and things, anybody can just skew the data however they want to. So this could be, you know, most of the studies could have ended up like this one right here, where it shows that root beer, you know, doesn't grow very well and milk grows better than root beer, but they could have put this one as like, oh, well, there's only one study when there were hundreds of them that showed that milk grows better, like 35 centimeters, and root beer only grows 20 in this liquid, and they only had these two that actually showed that root beer grew the plants better than the milk did. All right, a graph is a representation of the data. Now, how do you want to represent the data is based on you, and some people are biased and they want to say that root beer, you know, is better for you than milk. And so they're going to show you the graphs that show that root beer grows plants better than milk. So just be aware of that kind of thing, because people are always trying to confuse you with different graphs, and it works pretty well sometimes. So, all right, they do a good job. Now here's a best fit curve line graph. Notice all the data points, and we just put a line through the middle of all of them so that you can kind of find averages and things like that. It makes it really easy to find averages. Okay, well, there's tons of dots, so I'll just put one through the middle, and I can kind of find what the average would be based on the data and using that line. So that's a great way to get averages. Now here's just a normal line graph, and it shows the usage share of web browsers. So these were the years I was in college, and the web browser I started using was, of course, Internet Explorer, because it was the most popular one. It was awesome and so cool. So I used Internet Explorer. Now, as I started going through school, I kind of found that it was slow, and I asked my buddies, hey, what do you use for your internet browser? And they all told me Mozilla Firefox, or Mozilla, however you say it, okay? Now, look at Chrome. This is what I use the most. You can actually see I'm using Chrome right now. So I'd never heard of Opera before. do use Safari quite a bit on my phone just because I have an Apple and it's, you know, the internet browser that comes on the phone. So I just use that one. Now, I want you to notice mobile versus desktop use. Here it is, this pink line. That's crazy. I bet you it's like up in here now. A lot of people use mobile, but you can use Chrome on mobile. I think you can use Internet Explorer. What do they call it now? They changed it. It's like Microsoft Edge. Yeah, Microsoft Edge now. Okay, but people are using mobile way more now. So, yeah, I bet you use mobile more than you use anything else. All right. Now, that's it for graphing and tables.